Why hello there, this is John. Hope you guys are doing alright. Oh, it's nice and sunny out here today. Well, it's back to working in the motorhome, and what I'm going to do is put an inverter that takes 48 volts and pushes it to 120 volts in case we need emergency electricity in the house. So I'm going to mount it, the switch and all that in here. I'm going to use one of these mounted in there. I've just took the screws out here, and as you see, there is actually enough room to mount it in there, which is great. Okay, we've got some foam back there, so yes, so that's the next thing to do. We've got two contactors here, so we're using low power to control high power, which will be the high power will be the inverter. This is a basic diagram of what's inside a contactor. There is a coil in blue and a plunger in orange, and there are big contacts in red. So what happens is, when you apply power to the blue coil, 48 volts, it will pull that orange plunger down, which makes contact between the two red nuts there. So it allows power to go through from one side to the other. So basically you've got small power, like half an amp, controlling large power, which is like 20 amps. And that's the reason we use this, small power to control big power. We start off with our battery bank that produces 48 volts. On the positive side, I've drawn in red line. On the negative side, I've drawn in blue line, just to make it easy. From the positive terminal, we'll come out with a wire to a safety fuse, which is about 5 amps. And then from the other side of the fuse, we go up to an on-off switch, and from there we go up to a 3-way switch, which selects power to either the left contactor or the right contactor. And at the other side of the coil, inside the contactor, the blue wire is the negative, and that returns the power back to the battery. This shows how the two 48 volt battery banks are used, so you end up with 110 volts out just putting in 48 volts. That's pretty good. So how it works, basically, see on the left battery, you're going from the positive terminal to a breaker, which is 15 amps, then the wire goes up into a contactor, and on the other side of the contactor, once the contactor coil is energized, it sends power up and into the inverter. Same on the right side battery, the power goes up the red, goes into the contactor, and when that contactor is energized, it allows power to go up and into the inverter. The negative, or the light blue wire, goes from the inverter all the way down to the negative of one battery bank and onto the negative of the other battery bank. So that's how this all works. And a turn on the inverter tells us that we've got 110 volts available. Hang on, I'll put it that way for you. Yeah, it shows you've got 110 volts, and the battery is looking pretty well charged there. I originally was going to put these contactors behind this panel, but the problem was that the wire I was using was solid, and it kept disconnecting from these little spade connectors at the back there. I changed the wire from solid wire into stranded wire, mounted these on the outside so I can see any problems that may arise. I'm sure it doesn't look too great, but I'm quite happy with it. So now we've got power here. If power goes out in the house, we just run an extension cord, and we've got a choice of 2 power banks to run things in the house. And these power banks are charged by the solar panels on the roof, and it's putting out, what, 58 volts there, charging up. And down here I've got a 3-way switch which can change from the solar panels on the roof, charging either this battery bank or that battery bank. That switch is the one that controls it. There you go, it says only 52 there. So now we'll charge the battery bank, which is the center battery bank here. You know, you see on the news, they're always talking about, oh, we're going to lose power in the winter, blah, blah, blah. Well, guess what? We're going to be ready should it happen. All right, thanks for watching. Bye-bye.